Hi, I'm Sean with Mastering Math, and we're talking about a question that Kathy posted earlier today about a very, very lucky Tom Turkey who has a Thanksgiving feast on this table, which is a very strange table. The table has a constant area of 100 square yards, and this table is increasing in length by 2 yards per minute, which, okay, maybe Tom Turkey really wants to get at those mashed potatoes, who knows? So we are being asked to figure out how quickly the width is changing on this table when the width is at 5 yards. So I've made a summary here of the variables and expressions that we're going to be working with. So our area A is 100 square yards, width is 5 yards. That lets us figure out what length is, and that would be 100 divided by 5, which gives us 20 yards. We're also told about rates of change. So we're told that the table is changing length, the table is changing width. So we need to deal with derivatives also. If we're talking about our standard formula for area, which area of a rectangle being length times width, then we have three quantities that are potentially changing: the area, the length, and the width. Well, we're lucky. We're told right up front that the area of this table is constant. So the rate of change of area with respect to time, so the derivative of A with respect to time, will be 0. We're told that the length of the table is increasing by 2 yards a minute. That tells us what dl dt is. That is the rate of change of length with respect to time. And finally, we are looking for what the rate of change of width is with respect to time. And we're hoping that we get a negative answer when we do this. Otherwise, we've done something wrong. So let's go ahead and do some calculations. So how do we get from this formula for area into something involving derivatives? Well, we take the derivative. So let's take the derivative of A with respect to t, and that area will be calculating the derivative, that will be calculating that derivative of the product. And when we see derivatives of products, we automatically should think product rule. So the product rule will be the derivative of the first times the second one plus the first one times the derivative of the second one. And let's fill in some numbers. We know that dA dt is 0. dL dt is 2. Our W we're given as being 5. And next we're also given L essentially, because we know the area is 100, the width is 5, so L is 20. And then there's that thing that we don't know, dW dt. We can simplify this equation a little bit further. So 0 is equal to 10 plus 20 times dW dt. Let's go ahead and solve for dW dt. We'll add negative 10 rather, to both sides. So 20 times dW dt is equal to negative 10. Divide both sides by 20. That will give us dW dt is equal to negative 10 over 20, which is negative 1/2. And we need to remember our units. Our units would be in yards per minute. So look, we got a negative answer, which is what we expected. And what this is telling us is that the width of this table at this point in time is changing at negative 1/2 yards per minute. I'm glad that I got to work on this problem with you. If you want to talk about any other math with me, find me at Mastering Math. That's MAF Stirring Math. And I hope to talk to you soon.